Graphing in polynomial form. Now this is where we bring absolutely everything together. So here I have a polynomial and I'm like, crap, they've asked me to graph it. What am I going to do? This is a long process, so buckle up. First thing we have to do is find one factor. So we find one factor by using the remainder theorem. So remainder theorem, that's when we sub a number in to figure out if it is a factor. So remember, it's a factor if it equals 0. So 1 minus 2 is negative 1, minus 5 is negative 6, plus 6 is 0. So that means x minus 1 is a factor. Cool, so that's our first step. Next step, we want to fully factorize it, which means we're going to do long divisions, or equating equations, or synthetic if you are doing the cheats method. So this is a long process, so bear with me. So x times what gets me x cubed, x squared, multiply him by our factor, and then subtract him off. And then drop these guys down. Alright, then we go again. X times what gets me negative x squared? Well, negative x. Then we times him by both of those guys over there. Subtract him off. So that gets me negative 6x plus 6. Then we've got negative 6. Subtract him off, it equals 0. Perfect. So now I know my equation is x minus 1, x squared minus x minus 6, which I can fully factorize to that guy. So all I did was factorize the quadratic in that step. So now I can actually do my step of graphing it. And so for that I need my y-intercept, which I can actually get straight from my original equation, 0, 6, and my x-intercepts from my factorized form. So x-intercepts, x equals 1, 3, or negative 2. Now I have everything I need to graph him. 1, x, 6, 1, 3, negative 2. And we just try our best to play dot to dot. So while it is a long process, that is how we do it with a polynomial. So if you want to go straight into it, those are the questions you're doing. I'll go through this other example as well. It's the same sort of thing. So first step, remainder theorem. What fits into my equation so that he's going to equal 0? 4, 5, 6, 7. So if I do a 1. Because now I've got 1 minus 2 minus 4, which is minus 7, plus 7 is 0. So once again, x minus 1 is a factor. Okay, so let's go for a different method to fully factorize him now. We're going to use synthetic. We're going to use the dirty little synthetic method. So for synthetic, we use him. We only use the coefficients. Drop the first one down, then add, multiply, negative 3, add 4, 4, add 0. So because this was x cubed, this is now x squared, etc. So negative x squared minus 3x plus 7. So that is now my polynomial. That's how we factorize it. So then we want to do a couple more steps to fully factorize him if we can. Right, I'm going to take a negative out because he's kind of dirty and not working for me. Plus 3x minus 7. So now two things multiply to get me negative 7, add to get me 3. 7 and 1. I can't think of anything. Oh, because he's a 4. Shoot. That works much better. Plus 4 minus 4. So we're going to go x plus 4 and x minus 1. So this gets me x minus 1 squared, x plus 4. Hey, we've got a square bracket, which means we're going to have a bouncing graph. So my y-intercept, once again, I can actually get it from the original equation. And my x-intercepts, x equals 1 or negative 4. And this one is my double. Okay, so we graph what we can. My y-intercept is negative 4. I'm also going through negative 4, and 1 is my bounce. So I know he's going to be a bounce if I'm going from y-intercept to bounce. So that is something like what my graph should look like. So that's the full process. Have a go at them.